Okay, welcome all of you. So let us start. MCQs from kinetic theory of gases. That is we have started last time. Okay. Yes, I hope all of you can see the screen. So just read the question. Yes, last time हमने कुछ questions किए थे. मुझे लगता है 16 तक हमने किया था, राइट? और बाकी बताया था कि कुछ क्वेश्चंस जो है तो वो रेडिएशन पे भी बेस्ड है, तो इसलिए वो अभी हम नहीं करेंगे. बट जो काइनेटिक थ्योरी ऑफ गैसेस का जो फर्स्ट पार्ट जो हमने लास्ट टाइम डिस्कस किया था, उसके ऊपर जो बेस्ड क्वेश्चंस है तो वो हम अभी डिस्कस करेंगे. चलो ये 28 वाला देख सकते हो आराम से. रीड दिस 28. A cylinder fitted with a piston contains 0.2 moles of air at temperature 27 degrees Celsius. The piston is pushed so slowly that the air within the cylinder remains in thermal equilibrium with the surroundings. Find the approximate work done by the system if the final volume is twice the initial volume. It's okay. It's very, again, easy question because you have to be found out the work done in this process. And it is given that the system is in thermal equilibrium with the surroundings. What does it mean? That it is the process is carried out at constant temperature. That means it's going to be a isothermal process. So what is the formula for work done in isothermal process? You already learned it. It is simply nRT into log of V2 upon V1 to the base E. But if you want to convert this base to the base 10, then we'll have to multiply it by 2.303. But no need to do that because already the volume is given to be twice the initial one. And we already know the value of log of 2 to the base E, which is actually 0.693. Check. याद रखो ये बात ठीक से. 0.693. The value of log of 2 to the base E is going to be 0.693. If you don't know this, then you will have to just convert this log to the base E into the log to the base 10 by multiplying this whole equation by 2.303. Okay, so let us do that. So 2.303 multiplied by nRT into log of the same number, that is V2 upon V1, but now this time it will be at the base 10, no doubt. So that here it will be W, which is equal to 2.303 kept as it is into nRT as it is, and here log of V2 is given to be 2 times of V1, right? So that this V1 gets cancelled and we'll be left with log of 2 to the base 10. And we already know that the log of 2 to the base 10 is 0.3010. ओके, तो ये एनआरटी वैसे ही रखा, और यहाँ पे log of 2 to the base 10 क्या आएगा, 0.3010. Okay, and if you just multiply this together, 2.303 multiplied by 0.3010, it comes out to be actually 0.693, as we have seen it here. तो यही तो है वो वैल्यू जो log of 2 to the base e का वैल्यू है. तो अगर हमने यहाँ पे कन्वर्ट नहीं भी किया रहता, तभी भी यहाँ पे v2 के बदले 2 टाइम्स ऑफ v1, और यहाँ पे v1 के बदले एज इट इज v1 डाल के v1 कैंसिल हो जाता और log 2 यहाँ पे बचता, और log 2 to the base e जो है 0.693 ही बन जाता फिर एक बार. तो इसलिए यहाँ पे वैसे भी 0.693 आने वाला है, बट nrt is to be left and it is to be put here. So we have to put the value of nrt here. So this will be 0.693 as it is, which can be written as 0.7 approximately, and that is multiplied by number of moles, which is 0.2 here. So take it as 0.2, and that is multiplied by R. R is nothing but the ideal gas constant. So what is the ideal gas constant? It is going to be 8.314, which can be taken as 8 only approximately, and temperature, which is 27 degrees Celsius. So 27 degrees Celsius can be converted into Kelvin by adding 273 in it, which becomes 300 here. And hence, if we simplify this further, then we get, okay, 0.2 multiplied by 300, कितना बनता है? It will be 60, correct? Yes, 60. So here it is 0.7 approximately into 60 multiplied by 8.314, so that this 0.7 into 60 कितना बनता है? 50 नहीं 42, करेक्ट है? 7 6 जा 42, and point और एक 0 कैंसिल हो गया, and that is multiplied by 8.314. So in short, what we have to do is 42 multiplied by 8 simply. तो 42 को अगर 8 से मल्टीप्लाई करेंगे तो 4 8 जा 32, 320 या 350 के आसपास तो आंसर आना चाहिए. So you can select this 345 as a correct answer. Even you can just work this out and get correct accurate answer. Okay, if you want, you can just use the calculator to find this answer. 42 multiplied by 8.314, which is going to be 349.1, but it's okay, 345 can be used. Okay, chalo, next one. The molecular weights of oxygen and hydrogen are 32 and 2 respectively. The root mean square velocities of oxygen and hydrogen at NTP are in the ratio. Actually, this is based on simple fact that the RMS velocity of gas molecules is just inversely proportional to the square root of molar masses, because we have already proved that this C is equal to root of 3 RT upon M, correct? M naught, in fact. M naught matlab molar mass. So this shows that C is inversely proportional to root of M naught, which shows that C1 upon C2 is actually going to be root of M2 upon M1, right? So this is M2 upon M1, and hence we can just put these values here and get this root of. तो देखो हमको निकालना क्या है? मोलर वेट दिए हुए हैं और उनके रूट मीन स्क्वायर वेलोसिटीज ऑफ ऑक्सीजन टू हाइड्रोजन हमको निकालना है ना. तो ऑक्सीजन का ऊपर आना चाहिए और हाइड्रोजन का नीचे आना चाहिए. तो हाइड्रोजन का जो मोलर मास है वो उल्टा कर दो, ऊपर रखो. तो ये 2 यहाँ पे आएगा और 32 यहाँ पे आएगा. 2 1 जा 2 16 जा, and hence we get this 1 by 16 here. तो root of 1 by 16 मतलब कितना हो गया वो? 1 by 4 हो गया. So this is going to be the correct answer, which is present there in this option D here. Okay. Let us try this second question here. Number of molecules in 100 cc of gas at NTP if the mass of each molecule is given, and also the RMS speed of the molecules is given, that is 350 meter per second. Which formula we can use here? Who can tell me? We have the formula for pressure exerted by the gas, that is 1 by 3 n into m upon v into c square, where c is the CRMS. Okay, तो अभी इसमें हमको निकालना क्या है? Number of molecules निकालने हैं. That means n is to be found out here. So just revert this formula for n. तो n के लिए अगर ये formula rearrange करेंगे तो हमको मिलेगा 3pv divided by m into c square. Correct है? So just use this formula and get the answer. p कितना है? Pressure at NTP बोला है ना, तो NTP पे pressure कितना होता है? 1 atmospheric pressure के बराबर होता है. And 1 atmospheric pressure means it is 1.013 into 10 raised to 5 Newton per meter square pressure. Okay, this is 1 atmospheric pressure, and that is to be multiplied with volume 100 cc दिया हुआ है. But don't forget that cc has a conversion factor. cc is not a standard unit for the measurement of volume. It has to be converted into meter cube, and we know that 1 centimeter cube मतलब cc is actually 10 raised to minus 6 meter cube. So what does this 100 cc means? 100 cc का मतलब होगा 100 into 10 raised to minus 6, remember, and that is divided by mass of each molecule, which is going to be 4.556 into 10 raised to minus 25, and that is multiplied with c square, where c is going to be 350. So here it will be 350 multiplied by 350 once again, that is squared, and just work out all these calculations and get the final answer. So here it is. Yes, 3 into 1.013. 1.013 can be taken as 1 only, approximately. So take it as 3 here, multiplied by 10 raised to 5 into 10 raised to 2 comes out to be 10 raised to 7. And 10 raised to 7 minus 6 becomes 10 only. So here it is 10. And this 10 raised to 25 goes up. Okay, wait. तो यहाँ पे अभी 4.556 है, तो this is 4.556 into 350 into 350, तो ये 35 का स्क्वायर कितना बनता है हमको पता है 1225, करेक्ट है? तो ये हो गया 1225, and that is multiplied by 10 raised to 2, and here 10 raised to minus 25 combines with 10 raised to minus 23 here, so that this 10 raised to minus 23 goes up and becomes 10 raised to plus 23 plus into 10 raised to 1 comes out to be 10 raised to 24 as a final here. तो ये 10 raised to 24 तो आने वाला ही है, but what about this fraction here? तो ये बन गया 3 upon 4.5 into 12 to 5. 12 to 5 का 4 times भी कितना होता है? तो ऐसा करो, इसको रिड्यूस करो डायरेक्ट. 3 1 जा 3 4 जा and 0 जा and 3 6 जा. So almost 400 ही हो गया वो, right? So it's 400. Here it is 4.556 multiplied by 400. Sorry, 3 तो नहीं आएगा ना वहाँ पे, फिर 1 आएगा ऊपर. Yes, just work this out. 4 4 भी किया तो भी 16 होता है, तो almost 1 upon 1600 तो आने वाला ही है into 10 raised to 24. But if we cancel these two zeros here, then we can say this will be 1 upon 16 into 10 raised to 22, and 1 upon 16 is nothing but 0.0625 multiplied by 10 raised to 22 gives 6.25 into 10 raised to 20. So almost, yes, 5.4 into 10 raised to 20 will be the correct answer. ठीक है, यहाँ पे approximations भी किया ना हमने बहुत सारे, तो accordingly वो हम समझ सकते हैं, उतना तो चलेगा. ठीक है, go to the next question, third one. the difference between the principal specific heats of nitrogen is 300, then the ratio of two specific heats is 1.4, then value of Cp is, we want to find out the value of Cp, and the difference between the principal specific heats of the nitrogen is already given. Therefore, small Cp minus small Cv is given to be 300. But what is the formula? What is this equal to? It's actually equal to R upon m naught, if you remember. Okay, small Cp minus small Cv का वैल्यू कितना होता है? R upon m naught होता है. Actually, capital Cp minus capital Cv का वैल्यू R हुआ करता है. If we just divided this whole thing by m naught, that is the molar mass of the whole gas, then we can just get this capital Cp upon m naught to be left with small Cp, which is called as principal specific heat, minus this capital Cv upon m naught gives us this small Cv, which is called as a principal specific heat at constant volume, and this capital R upon m naught is also called as the small r, which is called as a specific gas constant, which is different for different gas, and hence we are going to get this as Cp minus Cv equal to R upon m naught. Okay, so for nitrogen के लिए क्या होता है? मोलर मास जो है उसका 28 हुआ करता है. So इससे हमको ये पता चलेगा कि small Cp minus small Cv can be written to be equal to R by 28. Okay, but since the difference in principal specific heat is given to be 300 joule per kilogram Kelvin here. अच्छा, बट यहाँ पे किलोग्राम है ना, तो यहाँ पे इसको हमको 28 को भी किलोग्राम में कन्वर्ट करके लेना पड़ेगा. So it will be 28 into 10 raised to minus 3 here, so that we can equate this. So R upon 28 into 10 raised to minus 3 can be equated with 300 here, so that we can get R from this. Okay, so R is actually going to be 28 into 300 into 10 raised to minus 3. Which can be written as, अच्छा 28 into 3 कितना होता है? 84 और ऊपर 2 zeros into 10 raised to minus 3. If you multiply this together, then we get this 8.4 simply. Yes, 8.4 approximately. This is the value of R, and what we want is Cp. What is the value of Cp? See here, Cp, अच्छा small Cp चाहिए ना हमको. Okay, तो small Cp के लिए क्या यूज करेंगे? देखो, इन दोनों का रेशियो जो है वो 1.4 दिया हुआ है, right? So small Cp minus small Cv equal to R होता है. तो but Cp is given to be 1.4 times of Cv. Why? Because the ratio of these two specific heats is given to be 1.4, right? So Cp can be written to be 1.4 into Cv. So if you put this value here in this formula, then we can solve this as, तो ऐसा करो, Cp को मत replace करो, Cv को replace करो. From this we can get that Cv is equal to Cp upon 1.4, right? ये तो ठीक है, कर सकते हो आप बाद में. तो Cp को अगर replace करते हो तो हमको मिलेगा 1.4 Cv minus Cv is equal to R, small r, and that is, and the small r itself is given to be 300. Okay, तो ये small r का ही वैल्यू 300 दिया हुआ है, डिफरेंस ना, तो 300 वो भी डाल देंगे यहाँ पे, तो ये बन गया इधर. और 1.4 Cv अगर कॉमन निकालते हैं तो अंदर बचेगा 1.4 minus 1, that is going to be equal to 300, right? So that we can get this Cv into 0.4 is equal to 300, which means Cv must be equal to 300 by 0.4, correct है? But we want Cp, right? तो Cp निकालने के लिए क्या करना पड़ेगा हमको? तो Cp can be written to be equal to 1.4 times of Cv, and Cv is already this 300 upon 0.4. Just simplify this further and get the final answer. what is this? 1.4 into 300 upon 0.4. If we remove this decimal point, then we can get this 14 into 300 upon 4. And if we just reduce this 4 with this 300, so 75 will be left behind. And here it is 14 multiplied by 75 will be the final answer. So CP value will be 14 multiplied by 75. How much it comes out to be?
1050.
Yes, 1050. That is going to be the final answer. Okay, the same unit, kilogram, joule per kilogram per Kelvin. Okay, so this A will be the correct option here. ये करो 10th वाला. One mole of an ideal gas requires 207 joules of heat to raise the temperature by 10 Kelvin when it is heated at constant pressure. Okay, तो अगर constant pressure पे heat किया जाए तो उसको 207 joules heat लगता है 10 Kelvin से temperature बढ़ाने के लिए. If the same gas is heated at constant volume to raise the temperature by 10 Kelvin, then the heat required will be. Yes, it's a very simple question again. We know that the dq is always equal to du plus dw, correct hai? This is the first law of thermodynamics we have already studied. Okay, so using that we'll see dq का formula क्या होता है? ncp/dt और du का होता है ncv/dt और dw का होता है nr/dt, correct है? So here we have to say that whatever amount of heat required at the constant pressure will be considered as dq, and if the same gas is heated at constant volume, so the heat and same temperature rise के लिए heat required हमको पूछा है, तो मतलब हमको यहाँ पे du निकालना है, correct है? Du is to be found out. What will be du here? Du will actually be equal to dq minus dw, right? Here dq can be replaced by 207, which is given already here, minus dw can be replaced by nr into dt, so that we get this 207 minus n. N matlab number of moles, which is already given to be 1 here, so we can replace it by 1 here, and r, that is the universal gas constant, which is already given to be 8.3 joule per mole Kelvin, standard unit, no need to convert anything, 8.3. Okay, and that is multiplied with change in temperature, which is already given here to be 10 Kelvin. So just replace it by that and just simplify this further, so as to get this 207 minus 83. How much it comes out to be? 124, correct? So it's 124 joule. This much is going to be the heat required in order to raise its temperature through 10 Kelvin at the same volume, constant pressure, constant volume. Okay. Yes. Let us see the next one. If gamma is 2.5 and volume is equal to 1/8 times of the initial volume, then the pressure P dash is equal to the volume is equal to 1/8 times of initial volume. Matlab, the gas is compressed actually suddenly, and the volume is compressed to 1/8 of initial volume. The pressure is equal to P dash is equal to, in terms of P, It's okay. It's very simple. In case of an adiabatic process, we know that PV raised to gamma remains constant. Correct? Hai? So if you use this, then we get just P1 V1 raised to gamma is equal to P2 V2 raised to gamma, and hence P1 is P1 only, and P2 is to be found out, and V1 is V1 and V2 are given. Relationship between V1 and V2 is given. It's given that the final volume V2 is just the 1/8 of initial volume, मतलब V1. So if you just replace this here, तो V2 के बदले अगर हम 1/8 of V1 डाल देंगे, तो देखो क्या मिलेगा, P1 into, नहीं तो ऐसा करेंगे इसको है ना, ठीक है, V1 रेस टू गैमा को नीचे भेज देंगे उस तरफ, वो साइड में, तो P1 कैन बी रिटन एज, ये तो उल्टा करते हैं चलो, तो P1 into V1 upon V2 the whole raised to gamma, that is going to be equal to P2 because P2 is to be found out, right? So if V1 upon V2 is to be found out, then this V2 equal to 1 upon 8 times of V1 gives V1 is equal to 8 times of V2. So if we just replace it here, then we get this P1 into V1 के बदले आगा 8 V2 upon V2, and that is raised to gamma, which is going to be P2. So V2 gets cancelled, and we are left with P1 into 8 raised to gamma, where gamma is already given. It's going to be 2.5, correct? 2.5. So 2.5 can be written as 5/2. So it will be P2 here. So that P2 can be written to be actually 8 raised to 5/2. मतलब ही क्या, 8 को हम लिख सकते हैं 2 raised to 3, right? तो ये बन गया 2 raised to 3 and the whole raised to 5/2, which also means that P2 is actually going to be 2 raised to 3 into 5/2. मतलब ही उसको हम लिख सकते हैं 2 raised to 15/2, which is already there in the option C here. So P dash is equal to 2 raised to 15/2 in this way. P into 2 raised to 15/2. Okay. ये करो 20 वाला. The specific heat of a hydrogen gas at constant pressure is Cp, which is equal to 3.4 into 10 raised to 3 calorie per kilogram per Kelvin degree Celsius. And at constant volume, it is 2.4 into 10 raised to 3 calorie per kilogram Kelvin or degree Celsius. If 1 kilogram of hydrogen gas is heated from 10 degrees Celsius to 20 degrees Celsius, then the external work done on the gas to maintain its constant pressure is, right? तो हमको यहाँ पे वर्क डन निकालने के लिए बोला है, बराबर? So see here, first of all, we'll just list out this Cp equal to 3.4 into 10 raised to 3 calorie per kilogram Celsius, and Cv is already going to be equal to 2.4 into 10 raised to 3 calorie per kilogram Celsius. Okay, so that the difference between these two, small Cp minus small Cv, actually comes out to be small r, which is nothing but capital R upon m naught, correct? So you can see this will be Cp minus Cv equal to r upon m naught, no doubt. इससे हम r निकाल सकते हैं, देखो, क्योंकि Cp हमको ऑलरेडी पता है, it is, अच्छा इसको 3.4 into 10 raised to 3 मतलब 3400 ही हो गया ना, वो 3400 लिख देंगे उसको, चलो ठीक है, 3400 माइनस Cv, स्मॉल Cv कितना है ये देखो, तो वो 2400 हो गया. So this is 2400. But don't forget that they have a common unit, that is calorie per kilogram degree Celsius. ये उनका कॉमन यूनिट है, जो कि उनके डिफरेंस का भी वही रहेगा. ठीक है, तो इसलिए R अपॉन एम नॉट. अच्छा, एम नॉट कितना होता है हाइड्रोजन का, पता है उनको. हाइड्रोजन का मोलर मास होता है 2. ओके, सो यहाँ पे 2 आ जाएगा. इसलिए R can be written to be equal to 2 times of this difference whole thing, that is 1000 only. That means R is going to be 2000 actually. So here it is going to be 2000, but that is again in calorie per kilogram Kelvin or kilogram into degree Celsius, right है. तो ये हमारा R मिल गया. ठीक है, but if you want to find out the external work done at constant pressure, and that is also when 1 kilogram of hydrogen is heated from 10 degrees Celsius to 20 degrees Celsius. So what is the formula for work done? Work done when the gas is heated from through at constant pressure. So it is going to be equal to actually P into delta V, but neither P neither delta V is given here. So we'll use this as nRdt, which is another formula for work done. So if you use it here, then we get this N. N matlab number of moles. How much it is given here? 1 kilogram of hydrogen gas बोला ही नहीं हमने. तो 1 किलोग्राम में कितने मोल्स होते हैं वो हमको ढूंढना पड़ेगा. अच्छा अच्छा, ओके ओके. Do one thing, that if suppose this moles is not present, then we can also use this another formula for nRdt. मतलब ये वर्क डन जो है होता है तो वो तो वैसे P into डेल्टा V होता है, नो डाउट. इसको हम NR डेल्टा T ऐसा भी लिख सकते हैं, या तो फिर कैपिटल M मतलब मास ऑफ द गैस मल्टीप्लाइड बाय स्मॉल r, दैट इज स्पेसिफिक गैस कांस्टेंट इनटू डेल्टा टी, ऐसा भी लिख सकते हैं. और उसका भी प्रूफ है, देख सकते हो आराम से. ये देखो, नंबर ऑफ मोल्स को कैसे लिखा जा सकता है. नंबर ऑफ मोल्स कैन बी फाउंड आउट एज मास ऑफ वन मोलर मास, करेक्ट है. दिस इज एंड दैट इज मल्टीप्लाइड बाय r इनटू डेल्टा टी, करेक्ट है. बट हियर वी कैन सी दैट दिस r अपॉन मोलर मास, यूनिवर्सल गैस कांस्टेंट अपॉन मोलर मास कितना बनता है, स्मॉल r बनता है. So we can write this as small r. So we get this capital M into small r into delta T here, right? So that we can just use it here. So instead of this nr delta T, we'll use mr delta T. Yes, and then just replace this small r. देखो यहाँ पे वर्क डन निकालने के लिए फिर हमको यहाँ पे स्मॉल r चाहिए और मास m भी चाहिए. m तो ऑलरेडी दिया हुआ है, it's given to be 1 kilogram, right? So it's replaced by 1 here. And small r, where it is? See here, this small r is nothing but the difference between the Cp and Cv, which is already obtained to be here, that is 1000. बराबर है, तो वो 1000 हम यहाँ पे रिप्लेस कर देंगे. But don't forget that it is going to be in calorie per kilogram degree Celsius, right? So the answer is going to be in calorie. Yes, so this is 1000 and that is multiplied by change in temperature. How much it is? 10 degrees Celsius to 20 degrees Celsius. मतलब 20 minus 10 कितना बन गया वो? 10 ही बन गया. So if we just simplify this further, then W becomes actually equal to 1000 multiplied by 10, which comes out to be 10,000. That is in calorie. Okay, that is 10 raised to 4 calories. This is going to be the actually work done. तो यहाँ पे कैपिटल आर निकालने की एक्चुअली जरूरत नहीं थी वैसे. स्मॉल आर जो है दैट इज द डिफरेंस बिटवीन सीपी एंड स्मॉल सीबी. ओके, दैट इज टू बी यूज्ड हियर इन ऑर्डर टू फाइंड आउट द वर्क डन. एंड वर्क डन का ये वाला फॉर्मूला जो है वो भी अच्छी तरह से याद रख लो, क्योंकि ये वाला तो हमको ऑलरेडी पता है. पी डेल्टा वी तो पता है, एनआर डेल्टा टी भी पता है, बट एन कैन बी रिटन एज मास अपॉन मोलर मास and r upon molar mass actually becomes small r, and hence we can also write that P into delta V, that is the work done by the gas, is actually equal to mass of the gas into small r, that is specific gas constant, that is multiplied by change in temperature as a final. So this is another formula for finding the work done, remember. Okay, ये 23 वाला बहुत इजी है. देखो, density of the gas is given here and the root mean square value of velocity of the gas molecules is also given. C दिया है रो भी दिया है. The pressure exerted by the gas on the walls of container vessel is simply P is equal to 1 by 3 into rho into C square. ये वाला formula use करना है. You can get the answer easily. Okay, no need to do actually. Next one, 24th one. The density of certain mass of the gas at STP is rho. If the pressure of the gas is doubled and the temperature is made 1/3, then the new density will be. Okay. Yes. देखो, density of the mass, certain mass of the gas at STP is already given to be rho. Okay. How the density depends on pressure and temperature at constant pressure और temperature पे density कैसे depend करता है. देखो ठीक से, P is going to be equal to 1 by 3 into rho into C square. करेक्ट है. बट इसमें C के बारे में कुछ भी नहीं बोला है, तो C has to be replaced. We know that C is going to be equal to root of 3RT upon m naught, where m naught is nothing but the molar mass. So if we replace it here, then we get this relationship between pressure and temperature, that is P is equal to 1 by 3 into rho into square root of 3RT upon m naught का square, जो बनता है simply 3RT upon m naught. So if we just transfer all the quantities in this other side here, then we get this density simply to be equal to 3 times of P into m naught upon, अच्छा 3 तो कैंसिल हो जाएगा, नो डाउट. And so this will be rho is equal to Pm naught upon RT. करेक्ट है, RT, that's it. So अभी देखो इसमें क्या हो रहा है कि the pressure of the gas is doubled. तो मतलब इस प्रेशर को हमने क्या किया, 2 टाइम्स कर दिया, राइट. और एट द सेम टाइम द टेम्परेचर इज मेड 1/3. okay, the temperature has been made 1/3. so yes, and molar mass तो चेंज नहीं होने वाला गैस, क्योंकि गैस तो हमने सेम रखा है, और R is constant only already. So using that we can say that since the pressure has been doubled and temperature has been 1/3, so density will become 6 times of its original value. Okay, density becomes 6 times of its original value. This is the final answer. But already density कितना दिया था, rho दिया था, so it will become 6 rho. That's all. Yes. Yes, can you solve this orally? The mean kinetic energy of per gas per gram molecule for homoatomic gas is given by per gram molecule, मतलब ही वो number of moles हो गया ना, so it is going to be 3/2 RT only. बाकी सब तो रेडिएशन के है. Okay, so we'll leave that for next time. So next time we'll see the concepts in radiation. Okay.